Intel's current Core-branded processors, which are found in the majority of desktops and laptops, are split into 3 ranges, with several models in each range. These ranges are called Core i3, or Core M3, Core i5 and Core i7, but the differences between the ranges aren't the same on laptop chips as on desktop. We'll explain the difference between laptop chips at the bottom of this article. The desktop chips follow a more logical pattern, so we'll cover them first. Many of the concepts and technologies we discuss, such as number of cores, cache, turbo boost and hyperthreading, are common across both desktop and laptop. For this reason, even if you're only considering buying a laptop, you should still read the desktop section before moving on to the laptop part of the article. In many ways, the desktop processors in the Core i3, i5 and i7 ranges are very similar to each other. All are based on the same key processor architecture, codenamed KB Lake for the latest generation, have the same instruction sets, the code that actually tells the processor what to do, fit in the same socket and have broadly similar graphics chipsets. Number of cores. The first thing you'll notice from the table is that Core i5 and i7 processors have 4 cores, while Core i3 models only have 2. Out of all the differences between the Intel processor ranges, this is the one that will affect performance the most. Each core is effectively its own processor. Your PC would still work, slowly, with just one core enabled. Having multiple cores means that the computer can work on more than one task at a time more efficiently, which will help keep your system running snappily even if you have tasks, such as an antivirus scan or video render, running in the background. Having several cores can also drastically increase the speed at which certain programs run. This doesn't apply to all applications, as creating software that takes advantage of multiple cores is difficult. While 2 cores are now the accepted minimum in a processor, if you generally only tend to have a handful of tabs open in a web browser and your most demanding application is a word processor, you won't see a huge benefit from a quad-core chip. However, modern games benefit from quad-core chips, as does video encoding. As an example, in the Geekbench Benchmark, which runs several tests optimized for single-core and for multi-core processing, the quad-core Intel Core i7 3770K machine being used to write this article scored 3422 in the single-core benchmark and 13401 in multi-core. With 2 cores disabled, the score was almost identical in single-core, but dropped to 7541 in the multi-core test. The maths add up: halve the cores, nearly halve the multi-core performance. What is turbo boost? The next item that may catch your eye is that the slowest Core i3 chips run at a faster speed than the base Core i5 and Core i7 models. This illustrates the perils of making a buying decision based purely on clock speed. Enter turbo boost. Primer: what is clock speed? The GHz figure you'll see represents the number of clock cycles, calculations, a processor can manage in a second. Put very simply, a bigger number means a faster processor. For example, 3.6 GHz means 3,600,000,000 clock cycles. This figure should never be used to compare processors from different families, generations or manufacturers, however. Bigger is not better when comparing AMD and Intel, or 2MD Gen to 7th Gen Intel processors. Different processor families have different levels of efficiency, so how much they get done with each clock cycle is more important than the GHz number itself. Turbo Boost dynamically increases the clock speed of Core i5 and i7 processors when more power is required. This means that the chip can draw less power, produce less heat, most of the time, and only boost when it needs to. Turbo boost means that the clock frequency figures in the table above are misleading. For example, although a Core i3 7300 runs at 4 GHz compared to 3.5 GHz for the Core i5 7600, the i5 chip can boost up to 4.1 GHz when required. so will end up being quicker. The more a processor boosts its clock speed, the more heat it will produce, so the processors can only turbo boost for a limited time while they remain within a certain temperature range. During long periods of heavy processor activity using all the processor's cores, such as video encoding, a chip may not turbo boost much at all as it might be too hot to do so safely. Turbo boost is a significant part of the reason Core i5 and Core i7 processors outperform Core i3 models in single-core optimized tasks, even though they have lower base clock speeds. Do I need hyperthreading? Next up is possibly the most confusing part of the spec sheet, hyperthreading. Confusing to explain as a concept, but also confusing as it's available on the top-end Core i7 and low-end Core i3 chips, but not the mid-range Core i5. Normally you'd expect to see more features added as you go up the processor range, but not here. Hyperthreading essentially tricks Windows into thinking that each physical processor core is in fact two virtual, logical, cores. The operating system can then share processing tasks between these virtual cores in order to help certain applications run more quickly, and to maintain system performance when more than one application is running at once. A 2-core Core i3 processor will appear as 4 virtual cores in Windows Task Manager, and a 4-core i7 chip will appear as 8 cores. On both our quad-core and a dual-core test system, hyperthreading increased the Geekbench 3 multi-core test score by 17%. Not double the speed, but a useful boost nonetheless. This performance increase will vary by program. Some software is much better at handling lots of threads. It's odd that the Core i5 chip misses out on this useful speed boosting technology, especially as it's present on the cheaper Core i3 models, so wouldn't appear to add anything to the cost of manufacturing a processor. It's possible hyperthreading is simply disabled on these models in order to give you a reason to buy a chip from the more expensive Core i7 range. Processor cache. Finally, we come to processor cache. This is a small section of memory built into the processor that stores copies of data present in the main system RAM. It takes much less time for a processor to grab data from this cache, so the time it takes to process that data is reduced. A larger cache means the chip will need to grab data from the PC's slower RAM less frequently, leading to faster performance. Only one Core i3 chip, the low-end Core i3 7100, has 3 MB cache, while all the rest have 4 MB. All Core i5 processors have 6 MB and Core i7s get 8 MB. Ultra-high-end Core i7 Extreme processors get even more. As the Core i7 chips also have hyperthreading, it's hard to test how much of their extra performance over i5 models is down to the extra cache. Cache shouldn't be as much of a factor in your buying decision as the other aspects we have discussed, but be assured that even the lowest Core i3 models have the same amount of cache per core as the Core i5s, so none of the processor ranges are crippled in this regard. Letters and suffixes. Some Intel desktop chips have suffixes, such as K, T or P. These special models have different characteristics than the stock versions. K denotes an unlocked clock multiplier, so if you have a compatible motherboard you can easily overclock the chip, raising its clock speed significantly for a serious speed increase. Overclocking can cause system instability and even damage your components, so should be approached with caution. An overclocked processor will generate an awful lot of heat, so you'll also need a decent third-party processor cooler to see any kind of decent stable overclock. There are 3 desktop Kaby Lake K processors, the Core i7 7700K, Core i5 7600K and Core i3 7350K. Bear in mind that these also use more power than non-K chips, even before overclocking. The Core i3 7350K has a 60 watts power rating compared to 51 watts for a normal Core i3, and the Core i5 and i7 processors are rated at 91 watts instead of 65 watts. T Suffix processors have lower clock speeds but also lower power requirements, and so are better for the planet and easier to keep cool. An example is the Core i5 7600T, which is clocked 700 MHz slower than the i5 7600 but has a 35 watts rather than 65 watts power draw. You'll typically find these inside smaller form factor PCs such as all-in-ones. All desktop Core i3, Core i5 and Core i7 processors have the same Intel HD 630 graphics chipset, but clock speeds vary between 1000 MHz and 1150 MHz. The graphics will likely be good enough for esports titles such as Overwatch at lower detail levels, but for any kind of serious gaming you should fit a discrete graphics card. See below. Choosing a processor for gaming. If you're going to play games at any kind of decent detail level, you should certainly buy a dedicated graphics card, but the choice of processor will also make a difference. You don't want your enthusiast GPU to be hobbled by a slow CPU, after all. You don't need to go overboard, though. For example, you usually won't gain much by choosing a Core i7 chip over a Core i5. As hyperthreading makes little difference in most games. Even complicated titles such as Battlefield 4 only really take advantage of 4 cores, so the extra 4 virtual cores hyperthreading provides won't be much use. There are exceptions, though. The latest Total War games appear to benefit from a Core i7's power due to the sheer number of units interacting with each other on the battlefield. If you're buying a desktop processor to play games, and aren't into hugely epic strategy titles, we say get a quad-core Core i5, and preferably the top-spec Core i5 7600K. If you ever find this processor is holding you back, you can always overclock it well beyond 4 GHz. Which processor should you choose? You should now be armed with enough information to make a proper choice about what sort of processor you need. We haven't yet reviewed the full line of the latest Kaby Lake processors. The previous generation of Skylake chips is very similar, however, so we'll refer to them here until we've had the full set under the microscope. Intel Core i3 6100 coming in at under £100. The i3 6100 is a great chip for low-end desktop builds that will mainly be used for word processing and web browsing work. It's capable of some decent single-core performances, too. The Kaby Lake version will be called the i3 7100. Intel Core i5 6600K rather more expensive at around £200. The i5 6600K is a great all-arounder, that's right, for overclocking, which makes it an excellent choice for gamers building a custom rig. It doesn't ship with a cooler, though, and if you're going to be overclocking you'll want to buy a fairly serious piece of kit to keep temperatures low. If you're not looking to overclock and want something a bit cheaper, the i5 6400 is a great alternative and comes with a cooler. The Kaby Lake version of these chips are called i5 7600K and i5 7400. Intel Core i7 6700K, the big daddy of Intel's Skylake line. The i7 6700K is a great processor for those who have high-end multimedia workloads, such as game streaming and video editing, or who just want to show off. It has overclocking ability, and you'll need to buy a separate cooler for it. As discussed above, if you're going to just be gaming, a Core i5 is a much better value bet. The Kaby Lake version of this chip is called the i7 7700K, which we have reviewed.